My dear students, in this video I am going to explain you the concepts of differential calculus. There are so many videos on this topic in YouTube, but here my aim is to make you the master of differential calculus of your own. Here you will get to learn where the calculus is used, how to use it, and the major mistakes done by the students to apply it. So don't skip and keep watching carefully till the end. I give you an example here. Suppose a car is moving with speed 20 meter per second and calculate the distance traveled by it for 10 seconds. Then we use the formula A is equal to Vt, and this is 20 into 10, that is 200 meter. If the speed of the car is changed and it is now 20t, where t is the time, then calculate distance traveled by the car for 10 seconds again. In this case, we can't use the ordinary formula S is equal to Vt, because we can use only S is equal to Vt whenever the acceleration of the car is 0. But here, speed of the car depends on time. That means speed increases with increasing time. Here acceleration is constant. So here we have to use calculus. Many students do a common mistake here. They put the value of t on velocity, that is 20 into 10, that is 200 meter per second, and again they use the formula S is equal to Vt, that is 200 into 10, that is 2000 meter. This is absolutely wrong. Whenever any physical quantity depends on another physical quantity, then only we can use calculus. Let us consider a physical quantity y depends on another physical quantity x, that is y is function of x. We can compare v and t in previous problem with y and x respectively, because speed depends on time, therefore v is function of time. Then we can use calculus here. Now I am explaining the basic theory of differential calculus. Here I consider a graph with x and y axis by plotting the variation of y with respect to x. Consider a point A on the curve here. Draw a tangent from point A. Make a line from A which is parallel to positive x-axis. Take an angle theta from that line to the tangent. Consider another point B near to A. Draw two perpendiculars from A and B on x-axis. C is a point where AC and BC are perpendicular to each other. Take AC as a small change of x, that is del x, and BC as a small change of y, that is del y. The slope of the graph is tan theta. This is equal to perpendicular by base, that is del y by del x, and this slope signifies the rate of change of y with respect to x. But the change of y is not same for the entire curve. If we draw a tangent at point B, this is not same as that of A. To get the rate of change of y with respect to x at point A and B should be very close. That means del x tends to 0. Then we can write limit del x tends to 0, del y by del x. This is equal to d dx of y. D dx, this is the differentiation operator. Where we can use differential calculus. Condition 1. To calculate any instantaneous value of a variable physical quantity, we can use differential calculus. I give you an example here. A car is moving and the distance traveled by the car is given as s is equal to 5t square, where t is the time, and we have to calculate the speed of the car at t is equal to 5 seconds. It signifies that our measurement of speed can be in between 4.59 second to 5.01 second. Therefore, the time interval is del t is equal to 0.02 second. If we compare this time with 5 seconds, then it is very small. Then we can say that del t tends to 0. We have learned that if any physical quantity y, this depends on x, that means y function of x, then we can use calculus, and here limit del x tends to 0, del y by del x, that can be represented as ddx of y. That means that physical quantity y can be differentiated with respect to x. Here if we compare it with our question, then x is here t and y is here s. That means s is function of time. That means displacement is function of time here. And limit del x tends to 0 here signifies that del t tends to 0. The limit signifies that the time interval should be very close to 0, but it is not 0. Therefore, in such cases, we can use differential calculus. Condition 2. For a particle in motion, to calculate speed of the particle from distance or velocity of the particle from displacement or acceleration of the particle from velocity, in such cases, we can use differential calculus if and only that physical quantity, that means displacement, speed, um, or distance, that all should be function of time. Here s is displacement, v is velocity, and a is acceleration. In general case, if acceleration is 0, then we write that v is equal to s by t. But if s is function of time here, then we can write v is equal to d dt of s. That means we can differentiate s with respect to time to calculate velocity. Similarly, we know that acceleration is velocity by time. That means change in velocity by change in time. Here, if velocity depends on time, that is v is function of time, then we can write a is equal to d dt of v. That means we can differentiate velocity with respect to time. Therefore, in motion problem, to calculate velocity from displacement or acceleration from velocity, in such type of cases, we can use differential calculus. Then condition 3. In graphical problem, to calculate slope of that graph, we can use differential calculus. We consider here displacement time graph. At any point, if we draw a tangent and calculate the slope, then here slope is equal to tan theta. This is del s by del t. As del t is very small, that is del t tends to 0, then we can write it as limit del t tends to 0, that is del s by del t. This is d dt of s. d dt of s means velocity of that particle at that particular point. Similarly, from velocity time graph, we can use acceleration by using slope, and that should be acceleration is equal to d dt of v. Condition 4. If we have to calculate the maximum or minimum value of any physical quantity, then we should use differential calculus. I give you an example here. Two identical positive charge Q are placed along y-axis at a distance d each from origin O. An electron is at a distance x on x-axis. The net force acting on electron due to positive charges is along x-axis and it is towards point O. Here K is the constant. We observe that the force is not constant here. It depends on x. Therefore, whenever electron moves along x-axis, the force increases, again decreases. So there is a particular value of x where the force is maximum, and we can calculate the maximum value of force using differentiation. Therefore, in such type of cases, whenever we have to calculate the maximum or minimum value of any variable physical quantity, then we have to use differential calculus. Condition 5. In pulley related problem or string related problem, even rod also, to calculate instantaneous velocity of two points or two bodies, we can use differential calculus. I give you an example here. Here a rod AB is inclined on wall. Point A touches the wall and point B on the floor. If all the surfaces are frictionless, the rod moves downwards. At any instant, the speed of point A is v, and if you want to calculate the speed of point B at that time, then we can use differential calculus. I think you got the ideas where should we use differential calculus. The next part of my video is how to use differential calculus. Let us consider y is equal to x to the power n. The basic formula of differential calculus is d dx of x to the power n. This is equal to n into x to the power n minus 1. If y is equal to x to the power 5, then d dx of x to the power 5, we can compare it as n is equal to 5. Then we can write 5 into x to the power 5 minus 1, that is 5 into x to the power 4. Therefore, differentiation of x to the power 5 with respect to x, this is 5 into x to the power 4. If y is equal to 10 into x to the power 5, then d dx of 10 into x to the power 5, here 10 is a constant, so it can be differentiated. So we are taking out 10 and we write here d dx of x to the power 5. If we compare it with the basic formula, then n is equal to 5, then 10 into 5 into x to the power n minus 1, that is 5 minus 1. So this is 50 x to the power 4. If y is equal to 1 by x square, then differentiation of 1 by x square with respect to x, that is d dx of 1 by x square, we can arrange it like d dx of x to the power minus 2. If we compare it with basic theory, then n is equal to here minus 2, then minus 2 into x to the power n minus 1, that is minus 2 minus 1, this is minus 2 into x to the power minus 3, this is minus 2 by x to the power 3. If y is equal to a here and a is not a function of x, then d dx of a, that we can write here a into d dx of 1, where we can write a into d dx of x to the power 0 also. Then here n is equal to 0, then a into 0 into x to the power 0 minus 1, that is 0. Then we can say that the differentiation of any constant that is 0. If y is equal to e to the power x, then d dx of e to the power x, this is equal to e to the power x. If y is equal to e to the power ax, where a is a constant, then we can take ax is equal to another variable, that is z. Then d dx of e to the power ax, this is equal to d dx of e to the power z. As e to the power z can be differentiated only by d dz, then we can arrange it like d dz of e to the power z into dz dx. E to the power dz can't be differentiated by d dx as it is function of z only. This rule is known as chain rule. Then comparing e to the power z dz with the basic theory here, we can write e to the power z into d dx of ax, putting the value of z here. As a is constant, then we can take out a, then we can write a into e to the power ax and d dx of x. The value of d dx of x, this is equal to 1, because we can write it as d dx of x to the power 1, and we can compare it with that formula d dx of x to the power n, that is n into x to the power n minus 1, and here n is equal to 1, so we can write 1 into x to the power n, that means 1 minus 1, that is 1 into x to the power 0, this is 1. Therefore, the differentiation of e to the power ax with respect to x, that is a into e to the power ax. We can differentiate trigonometrical function like sine, cos, tan. d dx of sine x, this is equal to cos x. d dx of cos x, this is equal to minus of sine x. d dx of sec x, this is equal to sec x tan x. d dx of tan x, this is equal to sec square x. d dx of cosec x, this is equal to minus cosec x cot x. d dx of cot x, this is equal to minus cosec square x. d dx of sine theta. If theta is not function of x, then we can't differentiate it. That is equal to 0. d dx of sine 5x. Take 5x as z, then write d dx of sine z. Here we can't differentiate sine z with respect to x, then use chain rule here, that is d dz of sine z into dz dx. Then differentiation of sine z with respect to z, that is cos z, and d dx of z, that is d dx of 5x, this is 5. So we can write 5 cos z, that is 5 cos 5x. If y is equal to log x base c, then differentiation of log x, this is equal to 1 by x. Now y is equal to log of sin x base c. Differentiating it with respect to x, that is ddx of log of sin x base c, we can consider sin x as z. Then we can write ddx of log z base c. Then using chain rule, d dz of log z base c into dz dx. Differentiation of log z, that is 1 by z, and we write ddx of sin x here. Putting the value of z here, that is sin x, and ddx of sin x, that is cos x, then this is cot x. If both u and v are function of x and y is equal to u plus v, then ddx of u plus v, this is equal to ddx of u plus ddx of v. Similarly, if y is equal to u minus v, then ddx of u minus v, this is equal to ddx of u minus ddx of v. If y is equal to u into v, then ddx of uv, here differentiate u with respect to x keeping v constant, that is du dx keeping here v constant, plus now u is constant and differentiating v with respect to x, that is ddx of v. If y is equal to u by v, then the differentiation of u by v with respect to x, this is v du dx minus of u dv dx divided by v square. We can solve this part ddx of u by v like ddx of u into v to the power minus 1. Then first differentiate u with respect to x keeping v constant, plus u is constant, and now ddx of v to the power minus 1. Here we can write 1 by v into ddx of u plus u into dd of v to the power minus 1 into dv dx. Then 1 by v du dx plus u into differentiation of d dv of v to the power minus 1. This is minus 1 into v to the power minus 1 minus 1. We compare it with that formula d dx of x to the power n, that is n into x to the power n minus 1. So this is minus 1 by v square. d dx of u and d dx of v, these are the differentiation part. We can add algebraically the coefficients of this differentiation part. Then we can write, I think you got the ideas how to use differential calculus. Already this video is long enough, so I am not discussing about the application of differential calculus and the major mistakes done by the students during solving numericals. There are different videos on this part in my channel. You can go through it. The links are given in the description box. To get such type of concepts of physics, subscribe our YouTube channel, and you can visit our free website Koushi.in, where you will get various concepts for your competitive exam.